Okay, this is a question asking about implicit differentiation, but not finding the equation of the tangent line, finding the equation of the normal line. There's two parts to this question. First, we should find the equation of that normal line, and then later on, they ask a second question, basically, which is find out where this normal line intersects the curve. So without being able to graph the curve, we can still answer this question. The question requires differentiation using implicit differentiation because of the fact that the x's and y's are all mixed in, and you can't solve for y in terms of x. And so implicit differentiation is where you take the derivative of the equation from left to right, both sides, and if you ever encounter the derivative of y, just remember that y is a separate function of x, which we can't express, so the chain rule comes in and we multiply by the derivative of y. You can use dy dx symbol, or you can use y prime. So we have this curve. Let me just write it larger here. X squared plus xy minus 2y squared equals to 0. And we're going to take the derivative. Officially, what's going on is we're doing this d dx. That's what it means to take the derivative. It's an x derivative that we're taking. And we're applying it to both sides of the equation. Okay. And so the derivative of x squared, let me go ahead and write it with the d dx symbol. So d dx of x squared plus d dx of xy. Let's see about this one. Let's go plus d dx of negative 2y squared. Take the negative with it and a 2. Equals to the d dx of 0. Basically, the derivative of the sum is the sum of the derivatives. Okay, the derivative of x squared is just 2x. The derivative of xy, we have to treat that like a product, where we treat x as our first function and y as our second function. So we take the derivative of x, which is going to be 1, and then we multiply that by just the second function. Don't do anything with it, y. Then we put a plus sign, and we leave the first function alone, x, and multiply that by the derivative of the second function. The second function is called y. It has a derivative of 1, but then we multiply by dy dx. Let me change colors on that. dy dx. Okay, I just put that all together, showing you that with the square brackets there, that came just from that one term. It required the product rule. Okay, great. We have this other term here, the derivative of negative 2y squared. That's negative 4y, but we're taking the derivative of a term with a y on it, so officially we have to multiply by dy dx. And then we have, on the right-hand side, derivative of 0, 0. Derivative of any constant is 0. Okay, now we need to use algebra at this point to solve for dy dx. And I'm going to do some skipping of steps. Hopefully that's okay. These terms that don't have dy dx in them, I'm going to move them over to the other side. If they're positive, I'm going to subtract them over. So on the other side of the equals, I'll have a negative 2x and a negative y. These guys that do have dy dx in them, I'm going to factor it out. If I factor dy dx out, I'll be left with an x minus 4y. Now, we're given a specific point. Like, we could find the formula for dy dx, but we're given a point. So we want it for this particular point when x is 1 and y is 1. And so why don't you just go ahead and plug in the fact that x is 1 and y is 1. So we'll have 1 minus 4 and negative 2 minus 1. Basically, we'll have that dy dx is a negative 3 on top of a negative 3. It is a 1. Now remember, though, this is the derivative. This is the tangent line slope. It's not what we need. We need the normal line slope. And the normal is perpendicular to the tangent. And so what we're going to do then is recognize that perpendicular lines have opposite reciprocal slopes. So our normal slope then is going to be -1. It's the we need the opposite reciprocal. Opposite, so it's positive, that makes it negative. Reciprocal, though, you know, reciprocal of 1 is 1. All right, great. So our normal line slope is -1. It goes through the point 1, 1. Let's just use y equals mx plus b. 1 equals -1 times 1 plus b, or that b equals 2, giving us our normal line equation to be y equals -x plus 2. Okay, great. Phase 1 is done. We found the normal line, but they ask a different question. They say, where does this normal line intersect the curve a second time? We know it's going to intersect at the point of tangency. Now we got to worry about where it intersects a second time. It's like you're solving two equations at one time. You have x squared plus xy minus 2y squared equals to 0, the original equation. And then we have y equals, it's okay if I write it as 2 minus x. It'll make it easier to plug in that way. And this is the normal line equation. And so normally, you know, we do some kind of elimination, but with all these squares, it's not a linear. So what we're going to do is substitution. Replace y with 2 minus x. Now we'll be solving both simultaneously. Find out where they intersect at. We'll have x squared plus x times 2 minus x minus 2 times 2 minus x quantity squared equals to 0. So we'll have x squared plus 2x minus x squared. They cancel out. Now when you square this 2 minus x squared, you'll get 4 minus 4x plus x squared. You'll have to distribute that 2 across. Let's go ahead and cancel these guys out. We'll have a minus 8, a plus 8x, and a minus 2x squared. Should be manageable enough to solve. On some of these MyMathLab versions of this question, it's unmanageable to solve this. And so don't be afraid to go to a calculator or a computer and just have them factor it for you. You know you've done it right when you get x equals the one value from before. And the question really is, what's the other value? And so what we're looking at then is going to be, if you're going to factor this, you're going to need the x squared term to be positive. So we'll have to move this guy over. These x's together give you 10. We'll move those over. So 2x squared minus 10x plus an 8. We're going to move the 8 over as well. And so take out a 2. And we'll have x squared minus 5x plus 4. And now we're in business. We can see how it factors. Signs are the same. They're both negative. And they two numbers are multiplied to give you 4. Add up to 5. 4 and 1. This is set equal to 0. So we already know that x equals 1 from the point of tangency. And now we have x equals 4. Okay. Now x equals 4. And the line of intersection was 2 minus x. Y equals that. And so y is going to be negative 2. So that's the other point of intersection. Let me just show you visually using a computer aided, grapher, like what we